So the reason why I tell you right now it's open note is so that you understand that you're going to be able to use this. So the notes that you make, that's up to you. So everything you write down right now, that's stuff you get to use. The area of a circle increases at a rate of 20 square inches per minute. Okay? Area of a circle increases at that rate. At what rate is the radius increasing when the radius is 5 inches? Sounds like a challenging problem, doesn't it? And I like to take these problems, throw them away. I like to take these problems and I like to start with, kind of a little bit descriptor and understanding what's changing. Circle's getting bigger, correct? It says it's increasing at a constant rate. So, what are the things that are changing in the problem? The area. What else is changing? The radius, the circumference, diameter. And I think that that's a pretty good list. Everybody agree that all those pieces are changing. Okay? We're concerned about the area and the radius. And we're concerned about rate. Understand we have a couple rates here. We have the rate of the area. We have the rate of the radius. We have multiple rates. Do you understand that? But in order to understand this section, this is the moment that you have to connect to. They are all changing with respect to something else. There's something else changing in this problem that you have not identified. Time. Give it up for Josie. Give her a round of applause. You see, time is changing. All of it is changing with respect to time. So related rates allows us to take multiple things that are changing, but they're changing with respect to a very specific variable, and that is time. And so it takes real world problems and makes them applicable. So here's what I'm going to have. I need a formula for area. What is area of a circle? Great. Now there's some things that we know. For example, we know the current rate at which the area is changing, or A prime. What is the rate at which the area is changing? 25. Right? What other thing do we know? I'm sorry, not 25, 20. Sorry. What other thing do we know in the problem? The radius is currently 5. Those are the two things that we're given. We could probably figure out more things. For example, if the radius is 5, could we find the diameter? Yeah, could we find the circumference? Could we find the current area? We could find all those things. We maybe don't need them. We're going to pause for a second before we say we need them. What are we looking for? So we're looking for R prime. So what I'm going to do is I'm going to take the derivative with respect to time of area equals pi r squared. Now I'm just going to bring you back here for a second so you can understand. I'm just going to connect this to a previous section that we did. If I have 2x squared plus y squared is equal to 9, okay, and I take the derivative with respect to x, what did we say was the derivative of 2x squared? 4x. What did we say was the derivative of y squared? And the derivative of 9 was. So understand that when we were taking the derivative with respect to x, we didn't have to list an x prime. Get that? But when we're taking the derivative of y squared with respect to x, we had to list a y prime. See that? So the same thing's going to happen here, okay? Do you see the variable t pop up in this at all? So we're going to have to list a prime for each variable then. So what's the derivative of area? We'll get to that in a second. Derivative of a is 1 times a prime, right? The derivative of y, you would say, is 1 times y prime, right? So derivative of a is a prime. Pi r squared. Pi is just a constant. So if we take the derivative of pi r squared, 2 pi r, r prime. So you attach, okay, an a prime, you attach an r prime, because you're not taking the derivative with respect to area, you're not taking the derivative with respect to r, you're taking the derivative with respect to time. Okay, now we look at our knowns and our unknowns. What is a prime? It's 20 is equal to 2 times pi times, what is r? 5 times r prime. Are we now going to be able to solve for r prime? Easy. We got 20 is equal to 10 pi r prime. Divide both sides by 10 pi. And we get r prime is equal to 2 over pi. And what is our label? Inches. The radius is changing in inches per minute. Not too bad, huh? Good. Okay, bring it up, say it, Cully, say it. No, why? Because what are we measuring? Measuring the radius. Do you measure, is radius a one dimension or a two dimension object? One dimension, right? Is area one dimension or two dimension? Two. Is volume 1, 2, or 3? 3. So you got to think about the dimension that you're using. See what I'm saying? So if it's a radius, that's just a single dimension measurement. So it's just inches per second or minute or whatever it was. Does that help you? Think of that. Okay, basketball. Well, what's different about this one? It's not a circle, it's a sphere. It's my best shot at a sphere. Sydney thinks I have a horrible sphere. It's being filled with air at a rate of 1 cubic centimeter per second. 1 cubic centimeter per second. At what rate is the radius increasing when the radius is 12? Very similar to the last problem, right? Except what's the formula this time? What am I measuring? Volume. And the volume of a sphere, and this is why you're going to want your notes as well, the formula for volume of a sphere is 4/3 pi r cubed. Yo. Yes. Yep. Here's what you may not use. You may not have a partner. You may not use your phone. You may not use me. Anything else? Fair game. By phone, I mean any type of internet. Here we go. What am I given? What do I know in the problem? What do I know in the problem? Okay, radius is 12. What rate? Rate of change of the volume, V prime. V prime is 1. What am I looking for? R prime. Looks like it's going to set up very similar. I'm going to take the derivative with respect to time of V equals 4/3 pi r cubed. What is the derivative of V? V prime equals, what's the derivative of 4/3 pi r cubed? Rach? 4 pi r squared r prime. Okay, what do I know? V prime is 1 equals 4 pi times 12 squared times r prime. I should be able to find r prime now, right? Now in this situation, instead of leaving my answer in terms of pi, I'm going to write a decimal answer, okay? Because I will accept either or on the test, and you're going to see that the answer key is sometimes laid out in this way as well. You are 99% of the time going to be working in radians, okay? Doesn't matter in this problem, but so I go ahead and I take 1 and divide it by parentheses. Remember your parentheses, 4 pi times 144. And yeah, that's a small number, isn't it? 5.526 times 10 to the negative 4th. So it would be 0.00055. And what's our measurement in? Centimeters per second. Okay. There you have it. Now, I wrote down that last year on this day we did get through one more example, but I want to turn to you. I want you to see some of your options for homework at this point.